So last class period, we talked about quadrantal angles. We talked about a few other things. We're going to extend that a little bit, and we're going to talk about reference angles. So a reference angle, theta, is formed by the terminal side of your angle and the x-axis. So I know you're probably like, what does that mean? So we already talked about this literally the first day that we went through these notes. We said that the initial side is along the x-axis. The terminal side is where your graph is, or your angle is going to. So this is creating your theta. So if it was in a counterclockwise motion, that's a positive angle. If it was going in a clockwise motion, that would be a negative angle. But either way, your terminal side is where your kind of angle ends. So what we're going to do is we're actually going to figure out from the items below, what are your reference angles? So I want you to know a couple things before I actually do this. So these numbers 1, 2, and 3 are your steps. So steps 1, 2, and 3, the first thing you're going to do is draw out where your angle is on the coordinate plane, as you've done before. The next thing you're going to do is you're going to draw a straight line up or down to the x-axis to create a right triangle. And then the last thing you're going to do is notice that your reference angle will be on the inside of your triangle at the origin. So closest to the origin is where your reference angle is going to be. So I just want to help you guys with identifying, okay, what's the point of this? What are you finding? The goal of finding this, or goal of this page, is to help you identify where the reference angle is in quadrant 1. So this helps you with identifying where your reference angle is in quadrant 1. And remember, quadrant 1 is between 0 is less than theta, which is less than 90 degrees. And it's the same thing as 0, not degrees, but 0 radians, so 0 pi, is less than or equal to theta, which is less than or equal to pi over 2. So I just want you to see what it looks like in radians and in degree. That's what quadrant 1 is. It's between 0 and 90, and that's a stubborn degree. It's between 0 and 90, and between 0 and pi over 2. That'll help us in a bit. All right, so let's graph these out. So we're going to start with letter A. There's methods to my madness. We're not going to immediately start with the negatives. So we're going to start with letter A, and then we're going to graph the rest of them. So to graph letter A, first thing we do is we put the 0. From there, I need to figure out, okay, well, where's 5 pi over 3? If you think back to the notes that we did before break, for instance, for this guy here, here's 0, pi over 3, 2 pi over 3, 5 pi over 3 is over here in this area. So the first thing I would suggest you guys do, don't just draw out where 5 pi over 3 is, because you won't always have it to where you have your notes or you have access to prior things that we've already done. What I would do is immediately draw out where pi is, because you know that pi is the same thing for this case as 3 pi over 3. Take that denominator and just literally put the numerator and denominator to be the same. So we're going to make this 3 pi over 3, which is the same thing as pi. It needs to be on your unit circle. So I need to figure out. The first step said to draw the angle on the coordinate plane as you've done before. So we said that 5 pi over 3 is going to be somewhere over here. So we'll have 0 all the way over to 5 pi over 3, which is right here. And remember, we talked about this again before. We said that whatever your denominator is, that tells you how many sections you're going to break the top part of your semicircle and the bottom part of your semicircle into. So this will create 3 sections up here, 3 sections down here to get to 3 pi or 6 pi over 3, which is over here. So here's 5 pi over 3. We found the first step. Step 2 says to draw a straight line up or down the x-axis to create a right triangle. So we're going to create a right triangle by going up to the x-axis, and I'm literally going to put a 90-degree angle. The angle that I need to find is this guy in here, that theta. So what you're technically finding, since theta is this whole angle, you're finding this length, what this is. So let me ask you, if you're going from 5 pi over 3 to 6 pi over 3, what's the distance between that? If you're going from 5 pi over 3 to 6 pi over 3. Pi over 3, that's all. That's your reference angle. Your reference angle is pi over 3. It's just telling you how far you are away from the x-axis. If you're looking at this, remember how I told you guys you're looking for your angle to be in quadrant 1? Well, quadrant 1 does have pi over 3. Pi over 3, which we did before, is going to be right up here. That's pi over 3. So that's perfect. That's exactly what I wanted. I want to figure out where 5 pi over 3 is going to reference in the first quadrant. So I know you're like, Ms. Tapia, this doesn't make much sense. Okay, let's look at a couple more, and after the next two, it should make a little more sense. Let's look at letter E. There's methods to my madness. Let's look at letter E. So we're going to draw out our coordinate plane. I'm going to put my unit circle around it. I won't always draw my unit circle, but for now I will. And I'm going to start this off. Okay, I have a denominator of 4. So if I'm going from 0 all the way over to pi, what's pi going to look like, Chelsea, if I need a denominator of 4? 4 pi over 4. That's exactly it, because when you reduce it, you'll get pi. So looking at 3 pi over 4, Chelsea, what quadrant do you think 3 pi over 4 is going to be in? Quadrant 2, you're absolutely right. Quadrant 2. This is where 3 pi over 4 is, and she didn't even look at her last notes. But if you look at the notes that we did before, 3 pi over 4 is in about quadrant 2. That's exactly it. Okay, so now I need to figure out. If I wanted to figure out where the reference angle is going to be in quadrant 1, I'm going to create a right triangle and reference theta. My thetas are going to keep getting smaller and smaller, guys. Just be careful. I need to figure out what this angle is going to be in radians. So, Jenny, give me a guess. What do you think theta is going to be? If you're going from 3 pi over 4, the closest angle I have is 4 pi over 4. What do you think it's going to be? Pi over 4. That's your reference angle. So that means in the first quadrant over here, pi over 4 is right about here. So this angle, we can reference the same coordinate, whatever that is, when we get to it, at pi over 4. Try G. At least graph out G before I do this one for you. Graph this out, and make sure you put your unit circle, that little dashed circle, all the way around it. Make your life easy. Start out by graphing where pi is, figure out where that's going to be, and then see what you're going to get. We have 0. If we go all the way over, and keep in mind, guys, I didn't put this for the other questions. You can put this if you want. We're going from 0 to 3 pi over 4. And we're going from 0 to 5 pi over 3. So I'm just giving you the direction to show that you're going in a counterclockwise motion, because y'all forget whenever it comes to like test and quiz time. So just make sure you put that little orange arrow showing where your angle is, that terminal side. Okay, so for 5 pi over 6, I would go from 0 immediately to 6 pi over 6, because that is going to be where pi is going to be once it reduces. Valeria, where's 5 pi over 6? What quadrant? Quadrant 2. So 5 pi over 6 is going to be somewhere here. This is 5 pi over 6. Let me draw my direction that I went to get here. And what I need to do is figure out what the reference angle is going to be. So we're going to have theta, and I need to figure out what is your reference angle here. Enya, what's your reference angle going to be here? You're going from 5 pi over 6 to 6 pi over 6. What's your reference angle? You're going from 5 pi over 6 to 6 pi over 6. What's the distance between that? Okay, so we're just going to write that as pi over 6. That's it. That's all you're doing. So what that references is where this angle will have the same coordinates in the first quadrant, which we'll get to more over the next several days. All right, for letter C, same thing. So far, if you're like, wait, these numbers look familiar. Yeah, because you've already seen these before. We've talked about the pi over 6s, the pi over 3s, the pi over 4s. We've already talked about all of them. Letter C, though, if you've been trying to cheat and use your prior notes, yeah, you can't do that for number C. The reason why is because you have pi over 12. Okay, for that, or excuse me, 7 pi over 12. With that 7 pi over 12, I haven't given you something that looks like that. So like I said, work smarter, not harder. Start with 0, and we're going to go all the way over to pi first. Pi is going to be the same as 12 pi over 12. My issue is I need to figure out where 7 pi over 12 is. Fatima, what quadrant do you think 7 pi over 12 is going to be in? I know it's going to be in 1 or 2, but which one? Why 2? It's greater than 6. Why are you saying greater than 6? Okay. And when you're talking about that 6, I'm assuming that's like 6 pi over 12. What is that equivalent to? Pi over 2, which is right up here. 6 pi over 12 is the same thing as pi over 2. If you think back to your notes that we've already done, guys, pi over 2 is straight up and down. That's 90 degrees. So if you can identify that as well, that'll help you with getting that little bit of an edge over where your line is supposed to be. But yes, Fatima is absolutely right. 7 pi over 12 is going to be somewhere in this quadrant. This is 7 pi over 12, and I went in this direction to get to it. So if I'm trying to find theta, which is going to be the distance from 7 pi over 12 to 12 pi over 12, Fatima, what do you think that reference angle is going to be? 5 pi over 12, that's exactly it. Your reference angle is going to equal 5 pi over 12. The only thing I want you to double check is 5 pi over 12 in quadrant 1? Yes, it is. Literally, 6 pi over 12, that whole thing that Fatima just said, she said 6 pi over 12 is at 90 degrees. 5 pi over 12 would be somewhere about here. So yeah, that's exactly what I want to see. So give me some nods or shakes. Does this make some sense on what you're doing? You're trying to find on the entire unit circle, where would the angles I give you show up in quadrant 1? What are they equivalent to? All right, so we've been dealing with positives. Let's deal with some negatives. So there's methods to my madness. I'm going to start with question H first, and then we're going to move up. So let's start with question H. I'm going to graph out my sketched unit circle. My unit circle will change probably every question, but you get the idea. Okay, so we're starting from 0, and this time it's negative. So negative goes in what type of direction? Clockwise. Okay, so clockwise means I need to go all the way over here to negative 3 pi over 3. And it's the same thing for positive 3 pi over 3. That location isn't going to change. Going in a counterclockwise or clockwise motion will get you to the same place as pi. That's why I like you guys starting with that. Okay, so this one's asking for negative 2 pi over 3. Itzel, what quadrant is negative 2 pi over 3 going to be in? This is 1, 2, 3, 4. Are you sure quadrant 4? Say it again. Quadrant 3, yes. Quadrant 3 is right here. This is negative 2 pi over 3. You're exactly right. Normally your brain would think, wait, it needs to be in quadrant 2. Yeah, it will be in quadrant 2 if it's positive, but since it's negative, we need to put it in quadrant 3. Just like we did before, I'm going to create a right triangle for this and find my theta. What you are finding is this angle measure, which is the distance from these two sides. So Itzel, what do you think your reference angle is going to be? If you're going from negative 2 pi over 3 to 3 pi over 3, what's your angle going to be? Negative pi over 3. I like what you said, but my only issue with that is that it needs to be in quadrant 1. What type of answers are in quadrant 1, guys? Positive. So I'm going to make a little note. Always must be positive. Literally, we did the all students take calculus. All of the answers in quadrant 1 are always going to be positive. So it's absolutely right. It is going to be negative pi over 3, but I want it to show up in quadrant 1. Right now with negative pi over 3, that's showing up in quadrant 4. All I'm going to do is just move it up into quadrant 1 because this unit of negative pi over 3 is the same distance here. It's the same pi over 3. So we're just going to make that a positive pi over 3. It's the exact same distance. I'm just making it positive. Give me some nods or shakes. Does that make sense? The only difference that you're doing after you do that subtraction like she just did, she's absolutely right. It is going to be negative, but we want it to show up in quadrant 1. That's the only reason why I didn't keep it negative. So reference angles are always going to have to be positive. So make this note, guys. Reference angles should always be positive. So if you need to put that and highlight it, go ahead. We're going to look at letter B, and then you guys are going to do D and F. So for letter B, we're going to graph it out. I understand that it's numbers, but you should be fine because these are degrees, so you should definitely know where this is. I'm going to draw my little unit circle. Here's 0, and we always have negative 180, which is pi, directly on the other side. It's right on the other side of the x-axis. Negative 130, Giselle, what quadrant does that fall in? Negative 130, what quadrant is that? quadrant 3. You're absolutely right. Quadrant 3, this is negative 130 degrees. So I need to figure out what's my reference angle. So Giselle, go ahead and subtract. If I'm going from negative 180 to negative 130, what's the angle going to be? Negative 50, but I want it to show up in quadrant 1. So what should I make it? Positive 50. So the reference angle is going to equal positive 50 degrees. Do letters D and F right now. Graph it out and then write out what your answer should be. I would definitely do these in pencil so that way if you mess up, you don't have to scratch out your work. Right now, go ahead and do letters D and F. All right, Melissa. That's all right. Let's look at D. We have negative 295 degrees. Okay, so the first thing that I'm hoping you did is you put your 0 and negative 180. What quadrant do you think negative 295 is going to be in? Not quite. Remember, you're going in a counterclockwise motion. Let me actually draw this out because I didn't do it for the last two. We're going in a, clockwise motion. So we're going this way. Same thing for this one down here. We're going in a clockwise motion to get here. So let's try this again. Where do you think you're going to go? Quadrant 1. The reason why is because if you're going in that clockwise motion, you're going to have negative 90 degrees to negative 180. This turns into negative 270. And if you go in a full circle, this is negative 360 degrees. Negative 295 is going to be somewhere about here. So my question to you is, do I need to find the reference angle or am I good? What does this say? So no, you can't just keep it as it is. You need to find the reference angle. So what I'm going to do is I'm going to draw my right triangle here. Here's theta, and I'm technically finding theta is this whole angle. So I need to find out what is this angle on your unit circle. So go ahead and subtract that and tell me what's your angle going to be. Joseph, what did you say? 65. Thank you. Your reference angle is going to be 65 degrees. And please make sure that that's positive. The whole point of me not keeping that negative 295 is because it was negative. If it was a positive 295, I don't know how that happened, but I could keep it. And it needs to definitely be between 0 and 90. So make sure whatever that number is going to be in between 0 and 90, and it's going to be positive. So if it was 295, actually, I can't keep that. It would need to be a positive number and be between 0 and 90. All right, for letter F, Heidi, what do you think your reference angle is for letter F? Oh, good. Let's figure out first where it is. So we have 0 here, and we have 2 pi over 2. Are you okay with that part so far? If I was to go in a full circle here, Heidi, what would this 2 pi be equal to with the denominator of 2? 4 pi over 2. What do you notice about 7 pi over 2 and 4 pi over 2? Is it going to be in this circle as it is right now? So let me write out what I have. We have pi over 2, 2 pi over 2. Down here will be 3 pi over 2, and then 4 pi over 2 is here. That is one full circle. I literally went in a full circle, and I still didn't hit 7 pi over 2. So Heidi, let's go around again. This side over here, we're just going to add 1, so that's going to be 5 pi over 2. What's this one going to turn into? You're good. And then down here is going to be what? All right, cool. We made it into another almost full circle, but here's 7 pi over 2. So in orange, this is my terminal side. Okay, I hope you agree with me. We can't create a triangle for this, can we? Okay, we can't create a triangle. We know it needs to lie between 0 and 90 degrees or between 0 and pi over 2. If I want this angle to show up in this first quadrant, what do you think your angle should be? 90, which is the same as what? Because remember, this is in radians. Pi over 2. It's in the same location as where pi over 2 is. So if it's going to be right directly on this line, guys, you're going to use your reference angle in the first quadrant. The only angle you can use is pi over 2. Give me some nods or shakes. Does this make a little bit of sense with what I just did? Anytime you have an angle directly on one of your sides and it's asking for a reference angle, use either this side, especially for if the pi over 2, 3 pi over 2, 7 pi over 2. If it was pi, or 3 pi for this case, what do you think your reference angle would be in the first quadrant?
0.
It will be 0, because it needs to be between 0 and pi over 2. Some students say, oh, why can't I use 2 pi? Is 2 pi between 0 and pi over 2? No, it's not. It's bigger. So for all of the ones for your reference angles at the top, that's all you're doing. You're just graphing it out to figure out where it will show up in your first quadrant. That's all. Give me some nods or shakes. How do you feel about this? Give me some nods or shakes. How do you feel about this? Okay, what's up? For F? Pi over 2. Is that okay? All right. All right, last bit. Let's look at number 8, or not number 8, example 2. So we're going to look at letters A and B. I'm going to do letter A. You're going to do letter B. So for letter A, the first thing we need to do is we need to sketch and determine its quadrant, find 2 coterminal angles, one positive, one negative, and find a reference angle. Okay, so let's graph this out. We haven't dealt with the denominator of 15, so let me graph out my unit circle that continuously changes. I just need a sketch. And since it's a positive 8 pi over 15, I can go from 0 over here to 15 pi over 15, because that reduces to just pi. Okay, I need to figure out where 8 pi over 15 is going to be. Gabriel, what quadrant do you think 8 pi over 15 is going to be in?
2.
Okay, why 2? Don't just tell me you guessed. Why bigger than 7? What's so important about 7?
Because 15 is bigger than 14.
Okay, and what's 15 divided by 2? It's about 7 point what? 7.5. It's about 7.5.
Smaller than 8.
7.5 over 15, that's the same thing as pi over 2, because we're literally taking half of 15. 7 pi over 15 is just going to reduce to pi over 2. Find that part first, especially for numbers that are this close. So if you're finding 8 pi over 15, yes, you're absolutely right. That's going to be in quadrant 2. So this point is 8 pi over 15. That's in quadrant 2. So one of the answers that it said was determine the quadrant. So let's write out quadrant 2. That's one of the answers that I need. The next part says find the coterminal angle and the reference angle. Since we've been doing reference angles for this entire page, let's just continue with this to find your reference angle. So if I wanted to find out my reference angle, I need to actually write this out and figure out what is the reference angle going from here to here. So between 8 pi over 15 and 15 pi over 15. Hussein, what do you think that reference angle is going to be?
It's going to be 7 pi over 15.
7 pi over 15. Let me double check. I'm pretty sure that he's right, but will 7 pi over 15 be in quadrant 1? How do you know? It's less than 7.5. That's why I'm telling you, it's important to put this part out, even if it's a decimal. 7 pi over 15 will be somewhere about here. So yes, that does show up in quadrant 1. My last question to you guys before I call on somebody specifically, how do I find coterminal angles? Say it again, Eurydia? Subtract and add what? Eurydia, what'd you say? Not quite 180 and not quite 365. When we did this, 360, yes. When we did this in class before today, we always added or subtracted 360. Because in order to be a coterminal angle, you need to rotate it around the entire unit circle one full time in order to get back on the exact same line. So whenever we did this with radians, we literally just added 2 pi and subtracted 2 pi, which is the same thing as 360. So on this page, what I'm going to do is I'm going to find 2 angles. If I was to rotate it all the way around in a counterclockwise motion, it should land right on top when you add 2 pi. So let me use blue. I'm going to do 18. Oh, that's not 18. That's 8 pi. We're going to do 8 pi over 15 plus 2 pi. And we're also going to go in a clockwise motion. So if you're going clockwise, it's going to go around this way, and you want it to land right on top. But remember, when you're doing clockwise, that's going to give you a negative answer. So 8 pi over 15 minus 2 pi. Good job. Good job with knowing that you're supposed to add and subtract something. That's extremely important. So all I need to do from here is actually find that number. So let me go ahead and simplify. We're going to make this 18 pi over 15 plus 2 is the same thing as 30 pi over 15. If you were to add that, that's going to give you 38 pi over 15. So what that means is, if I was to go in a counterclockwise motion, so I was going to go around this direction and come right back, it would land right back on top of 8 pi over 15, and it will equal 38 pi over 15. Let me do the same thing, but let me go in a clockwise direction. So if I'm on this side and I'm going in a clockwise direction, which is going to give me a negative answer, we're going to make this 8 pi over 15 minus 30 pi over 15. 30 minus 8 is what? 22? 22 pi over 15, right? What am I forgetting here? The negative. You have to have one that's negative and one that's positive. So this is at the same place as negative 22 pi over 15. And that says 22 pi over 15, by the way. So it's combining what you've already learned before today and what you just learned today. So right now, do number B, or letter B. I'm going to give you guys 3 minutes. Do letter B in its entirety. Graph it out. Give me the angles. I would probably do this in pencil in case you mess up. Just saying. I'm not solving anything. I'm just graphing out what you should be doing. Graph out your unit circle and plot where 19 pi over 12 is. All right, let's see what kind of stuff you guys got. So we have 0. This should be 12 pi over 12. Jesus, what quadrant is 19 pi over 12 in? Quadrant 3, here? Quadrant 4, there you go. 19 pi over 12 should be somewhere here. I'm probably not putting it in the exact spot, but this should be about where 19 pi over 12 is. This is 19 pi over 12. If you think about it, this is 6 pi over 12. Down here would be 18 pi over 12. So I probably should have put this a little closer, but it's okay. So the next thing you should have done was found out what your reference angle, or what your reference angle is. So let me write this out. Jesus told me this is in quadrant 4, so let me write that out. Quadrant 4, that's one of my answers. My reference angle, Valerie E. What's your reference angle here? What's theta? Pi over 12? Not quite. If you're going from 19 pi over 12 to, this is technically 24 pi over 12, because you're trying to find out what this angle is, try it again. Subtract it. There you go. 5 pi over 12. Much better. All right, Jacqueline, give me a positive coterminal angle. 43 pi over 12, so this is your positive coterminal angle, 43 pi over 12. Just add 2 pi to this. And then, Jorge, what's your negative coterminal angle?
Negative 5 pi.
You're good. That's it. Those are the exact ones I have. So we're going to be using reference angles for a while. So the homework that you have, any extra notes that I give you guys on this, make sure you practice it, because you're definitely going to need to know this over the next several days. Do y'all have any last questions before we move on?